Hey Math 1, I've got a new video for you. It's keeping the idea of proofwriting moving, but in a much simpler way than what order of operations proofwriting was. So, and this is sort of the last concept of the chapter. I've got one other video lesson after 1.9, but it's more of the same that you're seeing here. So, consider this. I've got 3 minus 8, parentheses, x minus 3 plus 4x. And the things that we should remember from the order of ops was that 8 put side by side with parentheses means multiply, okay? And then everything else seems a little straightforward. So the order of operations states inside the parentheses first. So x minus 3 would have to be the first calculation. However, because x and 3 are not what are called like terms, I'll talk about them later on down here, okay? You can't actually take x minus 3. X minus 3 is not 3x. X minus 3 does not equal 3x. Or negative 3x. They don't match up. So then you ask yourself, okay, what can I do? I'm supposed to multiply, but there are these parentheses here. How does that work? Well, there's this thing called the distributive property, which I'll talk about a little bit further down here, where you can take this 8, and since there's a minus in front of it, I'm going to carry that minus through with it. You can take a negative 8 and multiply by the parts inside the parentheses, and it breaks the parentheses open. So negative 8 times x is negative 8x. And negative 8 also times negative 3. A negative times a negative is a positive. It'll be 24. You know, the 4x wasn't a part of that crowd, and neither was the 3, so I just dropped them down. At this point, what I want to do is say, hey, the 3 and 24 look like they're compatible, but they're not side by side. So what we do is we use this thing called the commutative property to flip around the order. So negative 8x plus 24 is the same as plus 24 minus 8x. So see how I moved the left sign with it as it moved to the other spot. And then again, the 3 was not involved, neither was the 4x, so we dropped those down. Okay, now that I've got 3 plus 24 side by side, I can substitute 3 plus 24 with 27. And then negative 8x plus 4x, since they're both identical in their variables, I can combine the coefficients in front of them, the numbers that exist in front. So I can do negative 8 plus 4, which is minus 4, and just throw an x on there. And that's the answer. So the only proof writing you're doing is documenting the calculations, and I'm not going to ask you to put them off to the side, the calculation part. What I am going to ask you to do is say, on this first step, I use the distributive property to get rid of parentheses. That's what backed up that first move. On this second move, I showed that rearranging the terms can actually get the like terms side by side. So that's called the commutative property. And then on the last move, I used what's called the substitution method to simplify basic calculations. And that's basically what a combining like terms proof looks like. So let me go ahead and unpack that a little bit more. So let's take another look at these properties here. So here's what the definition of like terms actually looks like. Like terms have identical variable parts. What that means is that they have to have both the variables and the exponents. We haven't really talked too much about exponents other than in order of operations, but if the exponents are different, they are not like terms. So 5x and 8x, they're like terms, so we can add or subtract them. 7.2y and 9, they're like terms. It doesn't matter if one of the coefficients is a decimal. 15xy and 2/3 xy are like terms. It doesn't matter if one's a fraction and one's just maybe an integer or a whole number. As long as they have xx, yy, xy with an xy, they're good to be added to or subtracted from one another. 5x and 4y are not like terms because the x does not match up with this y. Much like 6xy is not the same as 7x squared y. 7x squared y is really like saying it's 7xxy. Two x's are being multiplied in that sequence. 6xy, I can't really break it down any further. But you can see how this is not identical. Not identical. So here's the procedure. You can add or subtract like terms, which basically means changing the coefficients and leaving the variables unchanged. So 5x plus 8x. Add the numbers out front, also known as the coefficients. 5 plus 8 is 13. The x's are unchanged. So this is not 13x squared. That's like a basic mistake that a lot of students make. Negative 4y minus 17y. Make sure if it's minus and you're taking away, that it's kind of like you're adding the two digits 4 plus 17 and then making it a negative on the end there. Notice that the y is not y squared. It's just y still. Same thing with 3.2 plus 9. It's 12.2xy. You cannot add or subtract unlike terms. Like down here, 5x plus 3y does not equal 8xy. That's kind of like saying, yeah, addition is the same as multiplication. It doesn't. It doesn't. X plus y does not equal xy. I mean, just think about x. What if x equals 3 and y equals 5? Does 3 plus 5 equal 3 times 5? No. 8 does not equal 15. I guess what I'm just trying to illustrate here is that, it logically fails when you try to do these false, gut feeling shortcuts. A lot of times they just don't work. And then down here, I laid out the properties for proof. There's only 3 of them, which is great news. The distributive property means getting rid of parentheses by multiplying the outside term, in this case 7, by each term on the inside. So 7 with this group right here, I took 7 times 4 to get 28. I took 7 times negative 3x to get negative 21. I took 7 times 2y to get positive 14y. So I can multiply unlike terms. I can multiply 7 times x because putting them side by side together is exactly what it means when you do multiply. X times y does equal xy. I don't have to be afraid of some weird kind of fake statement coming out of that. So hopefully distributive property is a familiar thing that makes sense. If it's new though, I hope that this video is demonstrating exactly what you got to do. If you've got an x on the outside of the parentheses, negative 9x times 4 will give you negative 9 times 4, negative 36, with an x tailed onto the end of it. Yeah, same thing about negative 9x times negative 3y. A negative times a negative is a positive. 9 times 3 is 27. x times y is xy. Yeah, and these other things just sort of really show you what the commutative property is doing. It's basically saying if you start here and you don't have like terms that are side by side, what you can do is reverse the terms. Just make sure that the negative 9x has the negative 9 carried along with it. Yeah, so if you look over here, it shows you exactly what changed. 7 minus 9x became negative 9x plus 7. That 7 had a y on it. 7y minus 9x equals negative 9x plus 7y. Yeah, so the commutative property works with addition, and it works when you carry the subtraction with it. There's also the commutative property for multiplication. So you see xy and yx. You can rewrite the yx as xy, because y times x is the same as x times y. Sorry, the light keeps changing here. I'll just use the stick. Y times x is equal to x times y. Yeah. And then the substitution property is basically it's almost like the last move you make when you're calculating things. So it's just saying, hey, I've got 6x minus 9x. Well, I'm going to replace that with the simplified version, negative 3x. Positive 7y minus 17y, that's negative 10y. Yeah, it's the property that justifies basic calculations. All right, so I'm going to do one more example on this video and then show you guys sort of, well, maybe 2 more examples on this video and then show the rest on a separate one. So let's try to keep both of these in sight at once if we can. Close enough, I think. Oh, that's making it worse. Okay, let's just go for it. So we've got this variable expression on the very first, if I keep scrolling down, this is the first expression. They state, the directions, simplify the following statements while proving your reasoning step by step. So the first step, I don't have any parentheses, no grouping symbols, so I don't have to use the distributive property. So I would not say the first step in this case would involve the distributive property. However, I see that this negative 3x needs to travel so that it's side by side with the 8x. So here's how I'm going to write it. Step 1 is 8x minus 3x, because I can flip it around once and then flip it around again. So the commutative property is sort of like this endless flipping of order of terms. You've got 6y that can be written side by side with negative 9y. And then the leftovers, you've got a negative 4 that can be written side by side with negative 7. So this is the rearranging step. The step where you rearrange it so that the like terms are side by side is the commutative property. It's this whole idea that, hey, the 6x and the negative 9x, they're separated. Let's rewrite it so that they are side by side. So you would point the arrow and say, commutative prop. Step 2, 8x minus 3x can be simplified to positive 5x. Yeah. Then you've got positive 6y minus 9y. 6 minus 9 is negative 3. And they have to have the variables unchanged. If you move that back up, I believe they talk about adding and subtracting variables. Leave them unchanged. And then take the Negative 4 minus 7. Like I said, if it starts negative and you're subtracting, that's like if you're on the number line, you're moving further left on the number line. 4 plus 7 is 11, and it's negative. Yeah, that's a substitution property. It's the property that justifies basic calculations. Wow, 2 steps. All right, I think I will stop this video, and then the next one will be just examples.